polynomial equations, we often list all of their solutions, real and complex. So that means we're going to have solutions that involve I as well. So for number 1, it says we have 4x squared plus 9 equals 0. Okay, this is what we would call the sum of two squares. When you have the sum of two things squared, there is no way to factor those. So a lot of people try, like they try to write like 2x plus 3 times 2x plus 3. But the thing that's wrong with this is the outer and inner would combine to be 6x. We don't have a 6x in that problem, right? So then they're like, well, what if we made it a minus? Well, that messes up the 9 then. Does that make sense? It would have to be a negative 9, not a positive. So we can't factor it. So if I'm solving this, I would just subtract the 9 over and then divide by 4. So you get x squared equals negative 9 over 4. And then we take the square root. And when we take a square root, plus or minus, right? So we're going to do the square root of the numerator and the square root of the denominator. So we end up getting x is equal to, so what's the square root of negative 9? What am I going to write there? 3i, right? And then the 4 is 2, so it's going to be plus or minus 3 over 2i. So you can put the I on the side, it can go on the top with the 3, it doesn't matter. It just can't go on the bottom. That would be weird. All right, so the next one looks a little challenging, but we notice that we have a common denominator, a GCF, a greatest common factor, of a 2y. So we pull out the 2y, and then we have y to the 4th plus 13y squared plus 36. And then we can actually factor. So that 2y stays out front, but notice how I have like a y to the 4th and a y squared. When you see that, go ahead and try to factor with like y squareds at the front. That way our outer and inner will combine to be something with y squared. So if I have y squared and y squared. So do you guys see what our numbers are? 9 and 4, right? And they are both positive. So you can check. The first terms make y to the 4th like we want. Outer and inner combine. It's 4y squared plus 9y squared. That makes 13y squared. And then our last is 9 times 4, which is 36, so it works. And again, we have these like sum of two squares. So we can't factor them, but we could set them equal to 0 and solve. So I'm going to have 2y equals 0. Anybody already know what we're going to have here? Yeah, so we're going to have plus or minus 3i and plus or minus 2i for the other one. Because when we take the square root, we get the square root of negative 9, which is plus or minus 3i. And I think I had you guys kind of trained last year if you were in my class to recognize those. So when, I don't know, when I circled 2y equals 0, y equals 0, right? So when you see something like x squared plus 25 equals 0, I want you to know immediately what the two answers are. So do you know when you see x squared plus 25 equals 0? 5i and negative 5i. So you shouldn't have to like overthink that. Okay, so the next one. So we get everything on one side. And we try to factor. And it doesn't work because we have 13 and 1. That's all we can use. And we cry a little bit. And then we, suck it up. And we're like, okay, we can do this. So what do? Quadratic formula. So x equals negative b plus or minus the square root of b squared minus 4ac all over 2a. So we have 16 minus 4 times 1 times 13 under the square root. So that's 16 minus 52. 4 times 13 is 52, which is negative 36. So I'm going to have 4 plus or minus the square root of negative 36 over 2. So what do I write for the square root of negative 36? 6i. So 4 plus or minus 6i over 2, which becomes 2 plus or minus 3i. So that's the answer there. So the 2 went into both things. You can do the little heart thing, remember. It goes into both. All right, get everything on one side. So I have 20x cubed minus 12x squared plus 5x minus 3 when I subtract the terms over. Subtract or add. And this has 4 terms, so what do we always try first? Yeah, factor by grouping. Sometimes factor by grouping doesn't work, and then that's going to be like the P over Q stuff, which we're going to review in a couple sections. Do you guys remember P over Q? It's my favorite theorem, rational roots theorem. It's pretty cool. But in this case, it does factor. So I can pull out an x squared, and I can actually pull out a number as well. Yeah, so I'm going to pull out a 4x squared. When I do, I end up getting 5x minus 3. Well, I know I want 5x minus 3 here, but I always have to pull out a number and a sign. So I'm going to pull out a plus and a 1, right? So I get 5x minus 3 multiplied by 4x squared plus 1 is all equal to 0. So now I set each one equal to 0. So the first one gives me 3 over 5, because I would add the 3 over, divide by 5. The second one's a little bit harder, so if you need to go off to the side and say 4x plus 1 equals 0, so that means 4x squared equals negative 1. So x squared equals negative 1/4. And then we take the square root of both the top and the bottom, right? And plus or minus. So we end up getting x equals plus or minus, what do we get? 1/2 I, exactly. So 1 on top, 2 on the bottom, and then I from the square root of the negative. So those are our 3 answers. All right, and then the last little thing, if you get to something like this, I feel like students make this so complicated sometimes. So I saw one like this in your book, and I was like, ooh, that's a good one. Because what students will do is they'll realize like it doesn't factor, and then they'll try to do the quadratic formula with fractions. Why? Why are we doing that? Let's not do quadratic formula with fractions. That sounds miserable. So what can we do to make it easier? We can clear our fractions first. So looking at our denominators, we have 8, 4, and 6. So what can I multiply through by to clear our fractions? 24, yeah. So if I take 24 and I multiply through by 7/8 x squared minus 3/4 x plus 5 over 6 and multiply the 24 by the 0, well, that's still just 0, right? Then we just do one thing at a time. So I have 24 times 7 over 8. So the 24 and 8 reduce down to 3. So I get 3 times 7 is 21. And then 24 and 4 reduce down to 6. So 6 times negative 3 is negative 18. And then 24 times 5 over 6 becomes 20. Yep. And now you can do quadratic formula. Yeah, the numbers will be big, but it will work out. So I'm just going to write etc. We know how to do the quadratic formula, right? All right, so I'm going to stop there, and then we'll do the